Length of a line segment. The length of a line segment formula given here is a tool that we can use to both classify and verify various objects in math. Before we start to use the tool of the length formula, I'd like to explain how it's made. So I've written it down here at the bottom of the left-hand side of your screen in gray, and I'll use my example up here to show you how that is made. So looking at the coordinates 1, 2, and 4, 6, I want to figure out how far that is. So what I'm going to do is make a right triangle. And if I make a right triangle, I can use Pythagorean theorem. So the length is C, and then these two sides don't matter. I'm going to say A and B. So to figure this out now, a squared plus b squared equals c squared. That is our Pythagorean theorem. So I'm going to start with c equals a squared plus b squared. Going back to our diagram now, I don't know the length of b or the length of a, but I can count the squares. So I've got from the corner here, moving upwards, 1, 2, 3, 4. So I know that length is 4, and I know that my A length is 3, because it's 3 squares and 4 squares. And a quick calculation of that, I can figure out what C is. So C squared equals 3 squared plus 4 squared, which equals 9 plus 16, which equals 25. I'm going to square root both sides, and I'm going to get C equals plus or minus 5. It is a length, so I throw away the negative value. So C, in this case, equals 5. So why not just use Pythagorean theorem all the time? Well, because it's not always easy to count on a grid what A and B are. So we've developed a formula. So looking at B first, we can see that B is vertical, and our vertical axis is y. So the distance between the bottom here and our original point is the change of y. So you take the top one and you subtract the bottom one. So b can be represented by the change of y, and change of y, if you remember from slope, is y2 minus y1. And the same can be said then for a, which will be the change of x, which is x2 minus x1. And if we make one more change to this diagram and turn C into length, or L, then we're almost there. So we take those three pieces and put it into Pythagorean theorem. So that means that length squared, or C, equals the change of y squared, or the change of x squared. I've got a there first, so I'll do the change of x. I'm going to put that in brackets. So the change of x is x2 minus x1. I'm going to square it, plus the change of y squared. Now, our formula is solving for L all by itself. And if you notice when I did the Pythagorean theorem, right near the end, I square rooted both sides. So I'm going to do that. I'm going to square root both sides. And that will give me L on the left, because the square root of L squared is L. And then I'm going to leave the right-hand side alone, because I can't reduce anything in there, because all I have is a pile of variables at this point. So I'm going to leave it alone and give me the ability to sub in values and use the formula. So that's it. So the length formula is the Pythagorean theorem, just altered for the situation. And that didn't take too long at all. So we went from two coordinates on a grid to Pythagorean theorem to the length formula. So it's the change of x plus the change of y. Both values are squared and square rooted. Okay, so let's do a couple of examples. So we're going to determine the length of the line segments below, and I'm going to show you the difference between an exact solution versus an approximate solution. So in this case, we got L equals change of x all squared plus the change of y all squared. Sub in my values. I always call the first coordinate I see number 1 and the second coordinate I see number 2. You can flip them around as long as you're consistent. It really doesn't matter. So now I will say 6 minus 9 plus 12 minus 16. The length then equals the square root of, and I'm going to keep this in brackets because 6 minus 9 is negative 3. Be really careful here, because if you take it outside of the bracket, it actually means something else. I'm going to continue on here, then I'll show you what I mean later. So that becomes negative 3 times negative 3. Negative times a negative is a positive. The same thing with 4. It becomes positive 16. L then equals the square root of 25. Now, be careful here a little bit, because when you square root 25, you'll get plus or minus 5. Please realize that a length can never be negative, so you discard it, and you're left with the length equaling 5. And that is your solution. So what I was talking about before is this step here, just to be a little bit careful. Keep those negative values in brackets. So I'll just scooch down a little bit. So negative 3 squared is not the same as negative 3 squared. The brackets make a difference. This is negative 3 times negative 3, which is positive 9. And this is negative 3 times 3, which is negative 9. So be really, really careful when you're dealing with negative values that are squared. Back up to my second example now. So here, again, I'll start with the formula. When I teach this, I like to have students practice writing the formula over and over again. And then eventually, you'll just memorize it. So it's the change of y squared, change of x squared, added together, just like Pythagorean theorem. So sub in my values. So it becomes 6 minus 3 plus 9 minus 1. So in this example, once we tidy up our brackets, 6 minus 3 is positive 3, so I don't need to throw a bracket there. And 9 minus 1 is 8, so again, no bracket required. And now we're going to get 9 plus 64, which is the square root of 73. Okay, so now exact solutions are length equals 5 and length equals 73, the square root of. An approximate solution will be when you square root that value, so the length is approximately 8.5 to 1 decimal place. So know the difference between exact and approximate, and there's a time and place for both of those solutions. My last explanation slide is about using the formula to classify a triangle by side length. Triangles come in 3 varieties. They are equilateral, in which case all 3 sides are the same. They can be isosceles, 2 sides the same, and they can be scalene, in which no sides are the same length. So to set this up, we are going to go alphabetically with our lengths. So length I'll start in the top left-hand corner with E. So E to D alphabetically would be DE. And then going from D to F, again alphabetically as you write your line segments. And then F to E would be E to F. Now just to help you see the X values and the Y values, I'm going to highlight the X values and then highlight the Y's. Okay, now I'm going to fill in the formula. So from D to E, I'm going to be consistent. Doesn't matter which one you call point number 1 or point number 2, but you must be consistent. So D to E would be 1 minus -3 bracket, bracket squared. So I went from D to E. We're adding, and now the change of Y, 3 minus 2 all squared. And now I'm going to go D to F. So now looking at my X coordinates at D, again I've got 1 minus -2, double bracket, square it, plus the change of Y, which is 3 minus -2, double bracket, and squared. And lastly, E to F. Here we go. E would be -3. F is -2, so minus -2. Those are the X values. Plus, and again starting from E, I'm being very consistent here, 2 minus -2, bracket, bracket, square. Okay, just extend your radical signs or your square root signs all the way through. And now that I've got it set up and I was careful with my numbers, now we're going to solve it. So I'm going to scooch in, make this bigger so I have some room on my screen, and I'm going to solve each one of these. So this is going to equal 1 minus -3 is 1 plus 3 all squared. And if you can do this tip in your head, go ahead. 3 minus 2 is 1. And now we're going to get 4 squared plus 1 squared. That's going to be 16 plus 1. And so that is the square root of 17. I'm going to leave it as an exact figure for now. Scrolling down to DF, I'll do the same process. So now that's going to equal 1 plus 2 all squared plus 3 plus 2 all squared. And then I'm going to get, I don't need a bracket anymore, I can get 3 squared plus 5 squared. And that is 9 plus 25, which is the square root of 34. Lastly, -3 minus -2 is going to be -3 plus 2 all squared. 2 minus -2 is 2 plus 2, again all squared. This becomes -1 squared, remember your brackets, plus 4 squared. And that becomes 1 plus 16, and that is square root of 17. So looking at it now, you've got two values that are the same, so therefore your triangle is isosceles. Okay? We have two sides the same. The second part of this question is to determine the perimeter of the triangle. And here we've got the square root of 17 plus the square root of 34 plus the square root of 17 equals the perimeter. So I've just taken those values from our calculations. And when you add all of those up, you are going to get 14.1. And that's an approximation. Thanks for listening.